Hello and welcome. I am Hyperbola and our today's topic is loci of points. Let us begin with the first topic by understanding what is meant by loci of point. So loci means it's nothing but loci is a plural form of locus. So let us understand the definition. What do you mean by locus of a point? By its definition. So definition. Locus of a point is path traced out by the point while moving in plane or space according to a given law. Or it can be specified as it is a path traced out by a point moving in a plane in a particular manner for one cycle of operation. It seems difficult, right? Don't worry. Let us understand this by taking one example based on locus or loci of points. Loci of points, in very easy words you can say, group of points when connected or joined by a line, it constructs the loci of points. So let us understand the first thing. So locus of point P moving in a plane or equidistance from a fixed point, or you can say a center. So let us take a fixed point like this. So this is nothing but O, your fixed point, and we might be having one another point which is point P at certain distance away from your point or center point O. And when we try to trace the circular motion of this point around your center O, then it is nothing but loci of point. So as you can see, there is one point constantly revolving around this circle, which says that when we try to trace the different position of this point P around its center point O, we might have this circular path generated, which is nothing but your loci of points. It's a group of points when we try to join in particular fashion, we are having this circular path generated. Now, so let us take one more example. So locus of point P moving in a plane and having equidistance from two planes, 2 points, right? So let us see the example. So first we try to take the 2 points, fixed points A and B on the positions. So these are nothing but our 2 fixed points. So let us join these 2 fixed points by a straight line now. So we have now joined these 2 points by a straight line. So now what we do is, now take out a rounder, put a rounder at point A, take any random distance and make one arc like this. Now take out a rounder and put at B and draw the arc by cutting or intersecting your previously drawn arc. After that, let us draw one vertical line from this both of the arc joining this arc. So which is nothing but what? Which is the line which is equidistant from your point A as well as your point B. So this is nothing but a locus of point P moving in this plane. So let us take this point. So as you can see, we will be taking one point, and as you can see, it is going up and down on this line, which is showing the locus of point when it is away from 2 fixed points and it is at equal distance. You might be having one straight line as an answer for locus of points for these cases. So we can have either a circular pattern generated by the locus of points, you can see on my left, or you can either generate this straight line depending upon your point is at equidistance from your single point or multiple points, right? Very easy. So problem number 1. So let us read the question and let us look in the diagram also at the same time. So this is our simple slider crank chain mechanism, and we have the example for this mechanism. So let us first understand the problem statement, then we try to understand and correlate with this diagram. So let us read the problem. So in a slider crank mechanism, the connection of rod is 160 mm and crank is 40 mm in length. The other end point of a connecting rod on a slider moves along a straight line passing through the center of crank rotation. Trace the locus of midpoint of the connecting rod. So there are a few of the terms. So let us first understand this term. The circle is nothing but your crank. So it is a different position of crank is shown by the circle. So the small portion which is connecting your point A to the center of circle, it is nothing but your crank. Now your AB, the longest link, it is known as your connecting rod, which connects between your crank and your piston here. This is your piston, it is a rectangular portion. Now Point P is the center point of your connecting rod. So these are the terms. So your connecting rod is 160 mm long. That means your length of AB is what? AB is equal to 160 mm. Second, your crank is 40 mm. That means your line connecting from your point A onto your circle to your center point. That means your radius of your circle is what? Which is 40 mm. And here we need to trace the path of your center point P. That means we need to just identify point P into our diagram, and we can trace the different position of your point P while the rotation of this crank. So now what happens? So in IC engine what happens? So when the piston slides in horizontal motion like this, the circle, the point A rotates into the circular fashion on the circle. So here we are having two motions simultaneously. Here there is a horizontal sliding motion of the piston generates a circular motion into your left hand side wheel. So what happens is when the piston moves ahead, the point A comes down, and when the piston moves backwards, the point A moves up. So we might have a circular motion generated into the wheel, and if we try to connect this wheel to your shaft or your wheels onto your vehicle, then your vehicle may run onto the roads. So now what we need to do, just whenever this example, this diagram is given, we need to first draw this diagram in order to start the example. So let us first draw one circle with the radius is equal to 40 mm. Why? Because it is said that crank is 40 mm. So crank is the smallest link. So the link from your point A to your center, it is nothing but what? It is your crank. So we have drawn this circle, and when we are drawing the circle, we need to divide the circle into 8 number of equal parts or either 12 number of equal parts. So here in our case, we have divided the circle into 8 number of equal parts by 45 degrees a single part. And if you don't know how to divide the circle into 8 parts, try to follow my previous videos on geometric construction, and you can learn how to divide any circle into 8 number of equal parts or either 12 number of equal parts. So we have drawn this circle. Then after what we need to do, we need to draw a straight line from the center. So we have drawn this straight line, and now what we need to do, so we need to draw a point of your connecting rod, right? So let us draw the point of your connecting rod like this. So we need to draw from each and every point. So here we are having a total of 8 points, while in the diagram there is we are having only a point. So we need to trace different motions of your connecting rod. We have divided this total motion into 8 slow motion parts, and now we will try to trace each of the parts separately. So what we need to do, we need to first draw one line from point number 1 like this. So as we have drawn this line from point number 1, we will be specifying this line as A1 B1, and we will be finding out the midpoint on this line. As you can see, so midpoint is nothing but what? P1. Then after we will try to draw another line from your point A2. We will try to specify this line as A2 B2, and we will locate point B2 on this. Similarly, we will try to draw the lines from A3, then A4, then we will try to draw the line from A5, then we will try to draw the line from A6, and finally we will try to draw the line from A7, and then after A8. So we have drawn total all the connecting rod lines from A1 till A8. So we are tracing a total of 8 position of your connecting rod, right? So now let us read the example. So here it is said that you need to trace the position of midpoint of the connecting rod. That means we need to change, or we need to trace the different position of your center point. So center point name is what? P. We need to just join the P1, P2, P3, P4 by a dark line. It will give us one curve which is nothing but a locus of point P or locus of midpoint P of your connecting rod A. So let us join this point. So after joining this point, as you can see, we might be having this curve which is nothing but the locus of your midpoint of connecting rod A. Very easy, we have done nothing, we have just plotted this diagram, we have divided the circle into 8 parts, we have divided the complete motion into 8 parts, and answer will come automatically, right? Very easy. So let us move to one another example. Problem number 2. In mechanism shown in figure, crank OA rotates about O, and endpoint B of the rod AB slides on a straight line. Trace the locus of point P on the rod AB, which is 40 centimeter away from B, for one complete revolution of crank OA. See here, the point P is not our midpoint, but it is the point which is 40 mm away from your B. Don't worry, it doesn't matter. So here let us observe the difference. So here now the offset slider crank chain is given. So you can see in first figure it was a straight line passing from O, and on the same straight line we are having our piston. But in this case you can see your center line of your crank and your piston center line are differing by 20 mm distance. So this is nothing but the offset of 20 mm. So your piston or your slider is 20 mm offset from your center line of your crank. This is known as offset slider crank chain. So let us solve this example. The example is similar. So what we need to do? We need to first start with the circle as usual. We need to just follow this course here same. Then after we will be dividing this circle into 8 number of equal parts. Let us give the numbering as A1, A2, A3, A4, A5, A6, A7 and A8. Then after what we need to do? We need to draw one center line first. Then after you need to draw one another line which is 20 mm apart, because now in this case what happens is your slider would be 20 mm away this line. So in first case what we have done is we have taken the different length of your connecting rod and we have plotted this connecting rod onto a center line of your circle, right? But in this case what happens is, as you can see, your slider is below your center line which is 20 mm below. So now you need to draw your all of the connecting rod onto this new line. That's the only difference. So let us start first. So let us take out your rounder. Let us take the dimension of your connecting rod. So what is the dimension of your connecting rod? Take out from the figure. So let us say here the dimension is given as 160 mm or whatever. So in examination there is certain dimension would be given. So let us say for example 160 mm is given as your connecting rod dimension. So let us take that dimension onto your rounder. Put your rounder at A1 center and try to plot one arc onto this line. So you might be having this line. After getting this line, as this line is from first point, so let us specify this as A1, B1, and let us mark your point P1, which is 40 mm away from your B1. So how to mark your point P1? So you need to use two rounders. First rounder you will use only for a connecting rod, for defining your connecting rod, which should be set at 160 mm, and let us take one another rounder and let us adjust it to the distance of 40 mm, because it is said that your point P is 40 mm away from your B. So adjust on your second rounder 40 mm, put your rounder at point B1 and let us take 40 mm distance, you might locate your point P1, right? It is very easy. Now let us take your rounder of a connecting rod which is 160 mm. So let us plot the connecting rod from the second point. So from point A2, let us draw one arc onto this line. You might be having this line. So let us specify this line as A2 B2 line and let us indicate your point P2 40 mm away from your B2. Right? Similarly, you need to plot for each of the point. From your A3 point, you will be drawing the line. From A4 point, you will be drawing the line. And you will be defining point A4. From A5 point, you will be drawing the line and defining P5 point. From A6 point, you will be drawing the line and defining your point P6. And similarly, you will be defining a line from A7 point, and you will be having this line. And finally, you need to draw a line from A8 point, and you must define your point center point P. After having all the points P, what you need to do? You need to join these points P by a smooth dark line like this, and you will be having this curve generated, which is nothing but your locus of point P for offset slider crank chain. You can see the figure is similar as compared to your previous example, but the chain was what? 20 mm distance from your center line. That is the only change, right? It is very much easy and simple, right? So practice these both examples. Now let us move to another example. So in the mechanism shown in figure, the connecting rod is constrained to pass through the trunnion at point D. Trace the locus of end point C on BC for one complete revolution of the crank. In figure, consider AB or your crank length as 30 mm. So we have this new kind of figure. Don't worry, we will be just drawing the same kind of the drawing once again. So let us first understand what do you mean by trunnion. So trunnion is a center fixed point which revolves onto its positions according to the rotation of your crank. So it is a fixed point placed at a certain distance which revolves at its center position without changing its location is known as a trunnion. So your link must at each moment must pass through that trunnion. So now all the dimensions are given. So let us start with drawing first by drawing a circle as usual. So here it is said that consider AB as 30 mm. So we have taken the radius of 30 mm, or either you can say 60 mm as a diameter. After drawing the circle, what we need to do? We need to divide the circle into 8 parts once again. So let us divide the circle into 8 parts. After dividing the circle into 8 number of equal parts, we need to give the dimension to that circle or notations to that circle as B1, B2, B3, B4, B5, B6, B7 and B8. Then after, let us locate this point D, which is a trunnion point, which is what? 12 mm below this center line of your circle and which is 70 mm away from your circle. So let us define this point D as a trunnion point. So what is our next task? We need to just construct this connecting rod from the trunnion point for each of the positions passing from B1 till B8 points. So let us take our scale and let us draw line from B1 like this, and which must pass from your trunnion point D. Now let us give this end point as your C1 number. Then after, let us draw one line from your B2 point. Let us draw this line. We will be having this end point as C. Let us draw one line from your B3 point and let us have a point C3. Similarly, we will drawing lines from each of the points until we reach the lines B8 point. After reaching a point B8, you need to draw this line from B8 also in order to specify your C8 point. So after getting all of these points, you need to simply connect the end points of your line, because it is said that try to trace out the end point of your connecting rod, which is the point C. So we have tried to trace out the end point of the connecting rod, and the shape which is generated is nothing but what? It is this shape. We need to draw this shape by a little bit darker color. So it is very easy. We are just following and we are drawing the line from the fixed point, and automatically we are having the endpoints generated like C1, C2, C3, C4, C5, C6, C7 and C8. And while connecting these points, we are having the locus of the point, which is known as this curve. Right? Very easy. So problem number 4. A link OA 80 mm long oscillates around point O 60 degrees to the right hand side and returns to its initial vertical position with uniform velocity. Meanwhile, the point P, which is initially at O, starts sliding down and reaches at endpoint A with uniform velocity. Draw the locus of point P, and this is the case for oscillating link. So here we might be having one oscillating link which oscillates about the center point like a pendulum. It is a case of pendulum, we can say, and the point travels from the starting point till end point in the vertical line by uniform velocity. So now let us draw one vertical line. So on this vertical line, your point B will start its motion from this point O, and it will reach to a point A in the final condition. At the same duration of time, what will happen? It will travel to a 60 degree right hand side of your point O, and it will come back to its initial position like this. So this is the final figure onto which we need to construct our loci of points. So here we will be dividing this vertical line into 8 number of equal parts. At the same time, we will be dividing this particular arc into 4 number of equal parts of 15 degrees each, because this is a total of 60 degrees. So if we divide this part into 4 number of equal parts, then each part would be consisting of 15 degrees. We have divided this vertical line into 8 number of equal parts because we will be tracing the 8 slow motion of your point travel, and we will be tracing its rotational motion also into some parts. So now let us give the numbering. So for vertical line, let's start numbering from the top point 0, 1, 2, 3, 4, 5, 6, 7, 8. And for this angle, what happens is it travels first to 60 degrees. So we will be starting from vertical point as A0, then A1, A2, A3, A4. Then we'll give numbering once again. Your point will come back. So we'll give the numbering as A5, A6, A7, and A8. A8 position, it will be at initial position, right? So we have divided this portion also into 8 number of equal parts. So now what will happen? As your point moves from vertically from 0 till 1, your point also moves from one portion on the right hand side into the other. So what we need to do, take out your rounder, take the dimension of 0 till 1 on the rounder from your vertical line, take O as a center, O1 as a radius, draw one arc until you reach the A1 line. So I have drawn this arc like this. Now for second position, now point moves little bit down from O till 2, and at the same time it may have turned to A2 on the right hand side. So what we need to do, you need to take O as a center, 2 as a radius. Let us draw the arc until you reach A2 line. Similarly, for third position, take O as a center, O3 as a radius, draw one arc until you reach A3 line. Take O as a center, O4 as a radius, draw one arc until you reach the line A4. Then after, take O as a center, O5 as a radius, draw one arc until you reach A5. Then after, let us take O as a center, O6 as a radius, let us draw one arc until you reach A6. Then after, let us take O as a center, O7 is a radius, let us draw arc, and finally your point will reach at final point, right? Thereafter, let us identify these points. So we'll start first by plotting a darker point onto that drawing to specify these points. So these are nothing but the locus of points, means a group of points generated. Afterwards, after defining this point, you need to just connect these points by a dark line. So first let us define these points. These are the points which are known as P points. So P points initial position what? It is point P as specified at O point, as you can see. Just beside your O point you can see this is starting point P. Then after we will give P1, P2, P3, P4, P5, P6, P7 and P8. After getting 8 of the points, you need to just simply connect these points by a darker line, as you can see, and this point also by a darker line. This curve is nothing but the locus of point while your point moves vertically on the straight line with a uniform velocity, as well as it also rotates on the right hand side by 60 degrees and it comes back to its initial position. Very easy. So it is a different example as compared to your previous example because it is a case of your oscillating link. So that is all from my side. If you have enjoyed my lecture and teaching style, do not forget to like, share and subscribe to my channel. If you have any doubts, any queries, feel free to ask and comment down below. Keep learning, stay connected. Bye bye.